Okay, we're going to be doing a little tutorial here on percent composition. And the biggest thing you need to know, first of all, is that percent composition is deals with percentages, of course, and that's always part over the whole times 100 tells us what percentage of an element and how much that element tends to be in a compound. And here's just one example. And it's different ways we can calculate it, but we're going to look at it. Probably the most common way is to looking at the formula and the different elements and assuming we have just 1 mole of that compound, because the percent composition of a compound won't change depending on the amount. So why not just choose 1 mole, and that'll typically be the easiest. And here's what it can tell us. Okay, essentially for potassium chromate, the percent of chromium, oxygen, and potassium by mass, in whether it's a gram, a pound, a mole, or a ton of it. And when you're looking at minerals and deciding if you want to actually dig up those minerals, it'll tell us, what percent or what mineral has the most percentage of some kind of metal that you want. And the nice thing about percentages is that it all has to add up to 100. So sometimes we just get experimental data. And when we get experimental data, it's part over the whole times 100. So a typical type problem is we have 13.6 grams of a compound containing only magnesium and oxygen. It decomposes. We get 5.4 grams of oxygen out. What's the percent of this compound? Now, it's pretty safe to assume that the rest of it's magnesium, right? And so we know the total of oxygen and we know the total of magnesium. And that's kind of the work that they've done here, okay? And again, to find percent, for instance, for magnesium, we'll take 8.2 over 13.68.60 grams of the compound total. So it's part over the whole times 100. And that's how we get the percent of magnesium, which in this case is 60.3%. So to find the amount of oxygen, we could also do it where we take the mass of the oxygen in the compound over the whole times 100. Or if we know that the only part stuff there is oxygen, we can just subtract 60.3 from 100 and know that we're going to get about 39.2 and or 0.7, excuse me. And that's what we end up getting. And those have to add up to be 100. But the most important way, which I think you'll see a lot of, is using subscripts. And so we're assuming that that's all that's in this compound is the elements that are present in the formula. And what's really cool, the easiest way to do it is, let's say we had the molar mass of this of some compound. So again, you take the mass of the element of 1 mole of that in 1 mole of the compound, then you take 1 mole of the compound itself, which is the molar mass, times 100. So if we were to look at this, propane is a big one. You might hear about the Paris Accords and global climate change and selling carbon, amounts. Well, here's a typical example. We can find the molar mass of all of this, and then the grams per mole. Excuse me, the grams for every 1 mole for the like 3 moles of carbon, and then we can find 8 moles of hydrogen, and that would be in 1 mole of the entire compound. And lo and behold, here's what they did, right? 3 moles times 12 is going to give me 36 grams for every 1 mole of propane that's due, and of that total, which is 44, 36 grams is due to the carbon. And again, 8 grams, because we have 8 times about 1, which is the molar mass of hydrogen. 8 grams is due to the hydrogen, and this is the total. So how do we find the percent of carbon and hydrogen? Well, again, it's part over the whole times 100, and that's what they've got right here. So we know for carbon, it's 36 over 44, part over the whole, assuming we have 1 mole of this stuff times 100. It's 81.8% by mass of carbon. Or, and to find the hydrogen, we could go through the same calcs using 8 grams over 44, or say, hey, 100, because those are the only 2 elements. Say 100% minus 81.8% must give us about 19.2% or about 18%. I think I may have done my math wrong there, but it does work out, and it does add up to be 100. So 82 plus 18 is about 100. And of course, they round quite a bit here. Okay, we can use this as a conversion factor. So sometimes when you know the percent comp, one of the things that they'll do also is they'll say, okay, you have like 55 million pounds of propane. how many pounds is due to carbon, how many pounds is due to hydrogen. And they call it a conversion factor. But again, we can just say 81% times however many pounds or grams or, as long as it's mass or tons, and we can get the amount by mass due to carbon and hydrogen. And basically, so what information can you get from the percent composition of a compound? Well, it's pretty cool because you can basically, for any amount of that compound, we can determine the number of grams of each element in there. And as we'll see or have seen or we'll see down the road, we can even work backwards now and find the chemical formula of it. But you're going to have to wait for that fun for a later date. So for instance, here's another one where they said calculate the mass. If you, let's say you've got 82 grams and there's propane, and we already know that about 18% of propane by mass is hydrogen. Well, then you just take 18% times of that 82 grams. And that tends to work out quite well. And again, they pretty much set it up and go to great lengths here, but we can find it's pretty straightforward. Whether you do it through this way or do it using percentages, it'll come out the same either way. And again, it should all add up to be 82 grams. So it's kind of nice because you can kind of check yourself as well. So once again, pretty cool because we can calculate all kinds of things. Now, here's the big question is, who really cares? The world's largest copper mine, which I think you can see from space, is in Utah. So they start digging someplace, and all of a sudden they find these really pretty copper ores. But before they decide they want to dig these things up, they actually do a percent composition on the ores themselves and say, okay, if I know what the percent composition is, and I know about how much this ore is here, how much copper am I really going to get? And is it worth it given the cost of having to dig? It's just one place where it comes in really, really handy. Okay, so thanks a lot. Have a great day. And don't forget to complete and take notes or to keep your notes on this flipped assignment. Thank you.